Lesson 7.1 talks about nth roots and rational exponents, and we're going to have to use our knowledge of exponent properties that we just went over in the last lesson in order to do this lesson. So first, a couple of things you need to think about. And the first is a very formal notation. It says the nth root of a to the p power is the same thing as a to the p over n. So what I've done is I've taken something that's written as a root and converted it into what we call a rational exponent. So I put it into more informal words for you over here. It says there's a root number up here in the corner, and then there's an exponent right here above the a, the base. And if you want to change this from a root notation to an exponent notation, what you're going to do is you're going to keep that base, but the fraction exponent is going to be your original exponent divided by whatever the root number is. So let's see a few examples of this property in either order. So first we have the third root of d squared. So remember the property said take the base, which is d, and then raise it to the root, or this, exponent divided by root number. So that'd be the 2 divided by the 3. So same thing here on number 4. We'd say e to the 2 divided by 4. Well, you'd never leave a fraction of 2/4, so we'd always change that to a reduced fraction, which is 1/2. So number 5 would be 3 to the 4/5. Number 6 would be 10 to the 4/4, but again, we would never leave it as 4/4. That becomes 10 to the 1st, or just 10. And then here on number 7, it's a little strange because you have two different bases. So you have e to the 2/3, but then you also have f. Now there's an invisible 1 for the f power, so it's f to the 1/3. So e to the 2/3, f to the 1/3. Now here we're going to take that property and go in reverse. So we need to kind of identify who's the base, who's the root number, who's the exponent. So here on number 8, our base is a 2, and the root number is the denominator, so it's a square root. Now if you just write a square root symbol like this, you don't have to put a little 2 in the corner. If you do, that's fine, it's just not necessary. And then again, the first power is also not necessary because we always assume a first power. So the answer of square root of 2 written like this would be perfect. Let's look at number 9. We've got a, and then we have the 5th power, and then a to the 3rd power. Sorry, 5th root, a to the 3rd power. Now, there's another way you can write this. Sometimes it would be wiser for us to take the power and put him outside of the radical. So some people choose to write this as the 5th root of a, quantity taken to the 3rd power. Now, neither way is more exciting to me. I don't really care which way you want to write it. But later on, when we try to reduce these radicals in our head, sometimes it's easier to take the root before you raise it to the power, or sometimes it's easier to take the power and then take it to the root. So number 10, we have the 5th root of 5 squared, which of course you could bring the 2 out and say it's really the 5th root of 5 quantity squared. Right, number 11, we have the 3rd root of x squared, or if you'd prefer to bring the squared outside, you could say you have the 3rd root of x quantity squared. And then here on number 12, we've got the 4th root of 4, and then if you put a first power, that's fine, but it's not necessary. Okay, so I want you to evaluate these next few examples. So I'm going to try to do this without a calculator, and I want you to do the same, because it is an important skill that you can do this without a calculator. So I'm going to rewrite this as the square root of 9, and then I'm actually going to put the 3rd power on the outside, and I'll tell you why. I know what the square root of 9 is. That's a really easy number for me to figure out. That's really a 3. So this problem really says take 3 to the 3rd power. So my answer for that problem is a 27. Now of course we could do that on our calculator. If you chose to do this on your calculator, you would have to type the original 9 and then a caret, and then make sure the 3/2 power is in parentheses. You're still going to get the right answer, and I know some of you are thinking, hey, that's quicker. Sometimes it is. but it is important that you know how to do this without a calculator. There will be a time in your life where I won't let you use a calculator to do this. So number 14, I'm going to take it first, I'm going to do the, fifth power, or fifth root of 32, and then I'm going to put the negative 2 outside. And I'll talk about why we're going to do this. Now, if you don't have a list of perfect squares, cubes, fourths, and fifths out in front of you, make sure you ask me for one, or if you're not going to get to me in time, just look online. I'm sure there's many lists of perfect squares, perfect cubes, perfect fourths, and perfect fifths. So the fifth root of 32, if you tried that on your calculator, is actually a 2. So this problem really says take 2 to the negative 2 power. Well, we know that negative means to flip to the other side of the fraction. So it's really 1 over 2 squared. And we know 1 over 2 squared is really a 1/4. Again, you could do that on the calculator. When it gave you a decimal, you'd have to hit math enter enter. But I want you to try doing this without a calculator. Alright, the next problem, I'm going to write it's the square root of 4 taken to the negative first power. Well, we know what the square root of 4 is. The square root of 4 is really a 2. So this is 2 to the negative 1, which of course is 1/2. Okay, here on number 16, we've got the square root of 16, and I'm going to take the fifth power on the outside. Well, I think you know what the square root of 16 is. That's a 4. And then here at this point, if you have to use your calculator to figure out what 4 to the fifth power is, that's fine, because frankly I don't even know that. So if I try that on my calculator, I get 1024. Then here on number 17, we've got the cube root of 27 taken to the negative 2 power. So the cube root of 27 is really a 3. So this problem really says 3 to the negative 2 power. And we know that that means we're going to have to flip 1 over 3 squared, which is 1 over 9. Again, all problems here could be done on our calculator. However, it's important you know how to do this without a calculator. Now the next section, there's no way to do this in your head. So on your calculator, you're going to have to type this in as best you can. And frankly, I always find it helpful to convert these to rational exponents before I start typing on my calculator, just because the rational or the radicals are a little difficult to find. They're not easily accessed on the home screen. So I'm going to rewrite this as 5 to the 3/4 power. So when you go to do this on your calc, you just got to make sure that you type the 5 and then you type the caret, and then your calculator understands that 3/4 is all of the exponent, so it needs to be in parentheses. So when you type that on your calculator, please try that. Make sure you do try it, don't just trust me. And it says we're on to the nearest hundredth, so 3.34 is the answer we're going to get. These next few problems will not be pretty answers. So number 19 we're going to rewrite as 3 to the 4/3 power. So on your calculator, 3 caret 4/3. And when you round to the nearest hundredth, you get 4.33. Now kind of strange, on number 20, 5 to the 3/3 power, that's really just going to end up being 5 to the first power. And I know what that is, that's a 5. That came out nice. Okay, more of the same. So the next, let's see, 10 problems, they just want you to rewrite these using rational exponents instead of radicals. So remember, it's whatever your base is, and then you take it to the power, or the exponent, divided by the root number. So here for number 1, our base is 11, his invisible power is a 1, and his root number is a 3, so it's 11 to the 1/3. Number 2 is going to be 5 to the 1/4. 3 is going to be 23 to the 1/5. I'm sure you get the idea here. I just want to jump ahead to number 9. Make sure you understand that when there's just a radical symbol and there's no number out in the corner, there's really an invisible 2 there, because those are always square roots. So number 9 is going to end up being 10 to the 1/2 power. So if it's okay with you, I want you to finish that set of examples there, and we're going to move on to the next section, which says rewrite using radical notation. So if we have a rational exponent, I want you to go backwards and write this in radical notation. Now I don't care if you write these with the power inside or outside. Actually, all the powers are 1, so this will be really easy to do. So this will be the cube root of 2. This will be the 4th root of 5. This will be the square root of 11. Again, remember, you don't have to put a little 2 out. We assume it's a square root if there's nothing there. This will be the 5th root of 6. This will be the 7th root of 23. Now notice, since all the powers are 1s, I'm not writing a 1, but you're welcome to do that. I'm going to skip ahead to the next section because that's pretty easy. This time they want you to evaluate. So they want you to come up with the actual answer, and if it's a decimal, you can go ahead and round to the nearest hundredth. So if you would like to do this on your calculator, that's fine. You'll either have to find the radicals under the math menu, or you'll have to change these to rational exponents. So for some of you, it is easier to type 8 caret 1/3 power, right, as opposed to finding the cube root somewhere on your calculator. But 8 to the 1/3 power, the cube root of 8 is a 2. That's a nice answer. These all in the section come out to really nice, lovely answers. So if you get a decimal in this section, you did it wrong. So the 4th root of 81, if you type that in as 81 to the 1/4, you would get an answer of 3. 5th root of 32, you're going to get an answer of 2. Now just so you know, if you're trying to type the 5th root on your calculator, let me go ahead and pull that up for you. Oops. That's not what I wanted to do. Alright, so when you type the 5th root, you have to type a 5 and then go to the math menu and then pull up what we call the x root, which is right there, the x root. And then you'll type a 32. And if you try to do any other type of root other than a square root or a cube root, that's how you're going to have to type it in. It's, in my opinion, a little bit tedious, but that's up to you. Yep. So, I think I'm going to let you go ahead and finish those notes up. If you have any questions, come see me before or after school or at lunch.